Lindo ver.
So it's so nice to see you guys here for this 15th year anniversary of REM, the Aapresid network. My name is José Luis Sorcin. I am a member of one regional office, and I'm also part for the past 2 years of the REM team as the deputy director up until today, where I will be filling in by Gabi Marcialetti. So it's a real pleasure for me to be here. It's an honor. I would like to thank Euge and Juan, who have asked me to facilitate this meeting. Hopefully, I will rise to the occasion and honor my role. And I would like to welcome you to the REM 15th year anniversary. You can see that there is no music for celebration. We are not going to waltz with my former colleague. We could also book a trip to Disneyland, but that will not happen either. But with our team, we thought about doing something that will be even better, a panel where we may take a look back on the 15 years of our network, taking a look at the lessons learned, both positive and negative. And the intention is for this to be a space to reflect on what road should be taken by our REM network. So I was asked to share these introductory words, and as I was thinking about what to say, I saw that the network has many slogans that the Apresid Congress has had in its different editions. Today's, or this edition's motto is open code and open source, and the 2003 edition of the Congress was realization, or realizing things. Someone realized back then that he couldn't face up to weeds all alone in the north, that there was something quite big coming up, and that something was needed to work this out. This person is here. His name is López, Anido. He was the creator and the first deputy director of the REM network. Pablo not only realized what was coming, but he did not wait. He refused to sit down and wait for someone to come over and work things out for him. Pablo was a really empowered person, so he felt really empowered, and that was the 2004 Congress motto. The motto had to do with empowerment, and it said the time for empowerment. That was the motto or the slogan for that edition of the Apresid Congress. And Pablo, generated the necessary actions to found the REM network in 2010. The REM network was born, and the time was right. It was the Kairos moment, yes, as the Greeks used to say. And why do I say that the time was just right? Because up until 2010, we had 4 reports of bioresistant weeds. From 2010 and 2015, 49 reports had been submitted. So right now it's 49. So there are 45 resistant biotypes. In 15 years, weeds have grown at a ratio of 3 resistant biotypes per year. So that's a rate that we've seen over the past years. So this network began to be developed as a kind of foresight for what was coming in our sector. So Pablo was not just generous enough to make it applicable to the members of the Apresid network, but he also wanted to apply this to everyone, because he thought and he knew that the problem with weeds was much, much larger. So he knew that this was a solution that had to reach everyone. And also, there were several researchers that got involved as well, because they devoted part of their valuable time as researchers to be part of something that, if created with everyone or by everyone as a crowdsourcing kind of thing, would be a lot of better. So this was collaborative intelligence. And this is how more and more researchers from INTA, from universities, from the private sector began to get involved. Many joined in a very generous way. And we have one such person today, Daniel Tuesca is a teacher at the chair of weeds in the University of Rosario. He's an expert on resistant. He was one of my teachers. He started teaching class when he was very, very young, and he was one of the first people to join in as part of the network. But as everything is connected, we realized that this entire machinery had to be applied to diseases and pests. So in 2019, our network began to cover pests and diseases. And this is how researchers such as Daniel Ploper joined in. He works at Obispo Colombres. And Mr. Peralta, Beto Peralta. He is the glue that binds the academia and the decision makers together, because there is a lot of information that is generated academically but which needs to be interpreted later on, the phenology of crops, stuff like that. So it's about taking the paper to the plot. So Beto is exactly that. He takes what's written on paper to hands-on on the plot. So, well, that is what we want to do as part of this panel. We want to see what the network has been able to contribute as part of its vision, and where do you think our network may be headed, and what is the evolution that we can see for pathophysiology, for weeds, for plants in general. So let's move on with our speakers. I will invite the first speaker. Daniel Tuesca is a biologist, head professor. I'm sorry, Pablo is first. So it's Daniel, Pablo. So Pablo is the creator. Pablo is an agronomist, a member of the steering committee of Aapresid between 2007 and 2018, a founding member of REM program, a founding member of Chacra Bandera Aapresid, and he's also a farmer, and he's a wine grower as well in Santiago del Estero. You have the floor, Pablo. All right. Thank you so much, Jose Luis, for your kind introduction. I really loved to hear what you had to say. Thank you so much. For me, it's a huge source of joy to be in this Congress. I can talk about our history because I have been involved in congresses of Aapresid for the past 30 years. Yesterday, I also actively participated in another panel, and I also witnessed several discussions, and I'm really surprised to see how many discussions refer to resistant weeds, and well, the turnout was just huge because there were not only people sitting down, but there were also people standing up while they were watching the discussions. So this bears proof to the fact that this is such a big problem. The first time that resistant weeds were dealt with in Aapresid was in 2007, and from then on, this was a recurrent subject across the following editions. So I will talk about evolution and adaptation, which is fundamental when we talk about weeds, and when we talk especially about resistant weeds. And as I said before, I think I am authoritative enough to talk about our history with resistant weeds over the past 30 years. I am a user of this problem. That is why I felt compelled to do something, because my problem started out with Amaranthus quitensis, which is resistant to ALS. That happened when I was way too young, living in the province of Tucumán, and all of a sudden it seemed to us that the herbicide had been wiped out of the face of the earth because we had applied $50 per hectare and the field was riddled with weeds. So I would like to start out with a statement that doesn't sound real, but people said it in congresses, in panels, when technology was ushered, this technology was ushered in. This is copied word for word from Monsanto's statement when he presented the RR soybeans. Complex transformations that were required for the development of glyphosate-tolerant crops would be unlikely to be duplicated in nature to obtain glyphosate-resistant wheats. So this resistant gene was taken out from a bacterium, and it was thought that this gene would be unable to evolve in the vegetable kingdom. So this statement was held as true. Farmers repeated this as if it were the Our Father. It was amazing how everyone believed in this so much. That is why later on down the road it was so difficult for us to realize that this statement was untrue. There were practically no weeds back then, but when you would go into the field, you would go to the field and see weeds that didn't exist because there were no weeds around. So people went from an expense of $50 per hectare, which was the RR technology back then, to $12 per hectare. And the repetition of glyphosate applications was done across the board on fallow year-round. So the agricultural context changed dramatically. No-till was added to this because this facilitated no-till. No-till became cheaper thanks to this new technology. So there was this drastic change in the agricultural ecosystem and the signals that we were sending out to the weeds. So that is why I will talk about evolution and adaptation, because in the face of this very big change in the agricultural environment, there was a reaction on the side of the weeds and how they evolved and adapted. So let's take a look down let's go down memory lane in a way. So this is a timeline. This begins with the evolution of the first seed-holding plants on land up until our current day, our present day. So these are the milestones that are important for me in connection with agriculture, of course. For me, year zero, in pretty much the same way as we talk about year zero, which is the birth of Christ, the year zero for agriculture was the Green Revolution. This happened 75 years ago. And Norman Borlaug, at that time, actually, he was a visitor and a speaker at these congresses several times, and I was fortunate enough to share discussion panels with him. So this guy began to focus on genetic enhancements, fertilization-resistant varieties so as to improve yield. He began to work with groups across the world, with Profertil here in Argentina. He was a very important person in the history of Aapresid as well. So this guy launched a farming revolution that was able to overcome a problem that had been present for 70,000 years. In 70,000 years, the human population was as much as 2.5 million inhabitants, but this was doubled, 2.5 billion, sorry. So, well, even though the world population grew despite hunger, extreme hunger, the famines, in 1970, the Nobel Prize for Peace was given to this guy because of the Green Revolution. A few years after the Green Revolution, 55 years later, the use of herbicides became mainstream. It went mainstream. If we think about the herbicide as a tool which is indispensable for us, we would be unable to practice agriculture without herbicides. Herbicides were not an ancestral technology. This technology, that of herbicides, has been in existence for only 55 years. Didn't exist before. And if we compare this with the evolution of seed-bearing plants, these plants have been in existence for the past 200 million years. So seed-bearing plants have been in existence for all that while. During this period, these plants generated dispersion, dormancy systems. They advanced across the terrestrial biomes of the world. They sustained the impact of meteorites. They were able to survive in spite of that. They became more variable. The entire variability of plants that we can see nowadays in the steppes, in the tropics, in the tundra, these are plants that have been evolving for the past 200 million years. Herbicides have existed for the past 55 years. Okay? Another point in our timeline is that 7,000 years ago, modern man appeared with a new cognitive system, and man or humans began to interact with these plants and also with animals, and they, through communication and through brainstorming and working out problems and observation and trial and error in the places where plants were born, humans were able to create agriculture, to invent agriculture, and that happened 10,000 years ago. So agriculture has existed for the past 10,000 years. Herbicides, 55 years. Okay, so farming co-evolved with something else. There were crops that co-evolved, plants that were useful, wheat. There was a co-evolution that began to happen for some species which adapted to man because man traveled everywhere and carried those plants with him. And together with that, other co-evolutions began to happen. On the one hand, there were fungi and pests that foraged on the plants produced by the humans. So this marks the onset and the advent of diseases and pests. And there was also another co-evolution happening, vegetable species that adapted to the environments created by humans in order to compete for resources. That is to say, if there was soil movement for greater fertility, weeds strided to build their way there, and this was just cool because humans produced these types of environments where productivity was important, and the weeds took advantage of all the things that they could feed on thanks to the soil. So, there was a lot of resource availability on the side of the first farmers. So this marks the birth or the advent of weeds, so to speak. 10,000 years ago, so weeds have existed for 10,000 years, and herbicides have existed for the past 55 years. So let us jump a little bit more into the future. Let us skip the Green Revolution. 30 years ago, that is in 1995, something appeared in Argentina that was quite weird. A weed that was highly susceptible to one family of herbicides. It was highly susceptible. It could be easily killed. A group of herbicides that had been created 5 years before, these were not the ancient herbicides. The ALS herbicides had been created and had been launched into the market only 5 years ago. So there was this group of plants that did not die when they had to die. And this was a huge problem. This originated simultaneously in Córdoba. As a matter of fact, Daniel's group and an expert from Brazil studied this, and they were able to work out this resistance. So this was the first resistant biotype in the country. And then it also appeared in Tucumán. There were 100,000 hectares back then. We would seed the plants in December because of rainfall. And Tucumán saw this as a huge problem because for 5 to 6 days, nobody knew what was going on. Then we learned our lesson. But back then, I was a farm manager. We had applied a $50 per hectare herbicide. Then we applied floriburon, which belongs to the same chemical book, and we kept on spending money dollar after dollar, and the field had become a sea of weeds. Of course, we blamed the sprayer, we blamed the guy that was responsible for spraying the field, and so on. In a way, we were fortunate enough, so to speak, because in 1997, RR soybean was launched, the glyphosate-resistant soybean. So this went unnoticed in a way. In the north, it lasted a little more because the first RR soybean leaves were not adapted to the north just then. And this is a very important landmark because when RR soybean was launched, there was a change in the companies. So far, companies were launching herbicide after herbicide like crazy. But from then on, and undoubtedly because there were problems for launching herbicides, which was difficult, at this point, what did companies say? Okay, let's pick up the older herbicides and let's apply them on crops. And this way we're going to improve weed control. We are not going to launch any new herbicides. So in the past 28 years, in those 28 years, no new herbicides were launched. What's the consequence of that? What's the implication of this philosophy? Because there was a change in the philosophy of weed control. They were able to achieve something very difficult. A broadleaf plant like soybean, which is a legume, shares a gene with maize, which is a grass, a C4 plant, a grass, which was domesticated in Mexico. And they had the same gene, and they shared some management factors that could actually be shared. So this really facilitated the weeds, because the weeds said, oh, this is great. The field has been leveled for us. It's a level field because now I will create a glyphosate-resistant biotype and I can mess up the soybean farms as well as the corn farms. So this was a mistake or something, an occurrence, which facilitated the homogenization of the context of the landscape and the environment.
Following the timeline, in 2006, that picture you see is a pretty historical picture because it's a plot I was working on. Is a Johnson grass that would not die. And this is a 2006 picture, but the truth is that this was going on since 2004, and I was 2 years without realizing that I had a resistant weed such as this. Although I had a terrible year a couple of years before, I always blame the fumigator. But yes, I sprayed 14 liters of glyphosate 5 times over the weed, and it doesn't die. So I then realized I did not know what to do. I call Aapresid then. Santiago, the coordinator, says, Pablo, I have no idea what we have to do with this. Let's call SENASA. So we called SENASA. SENASA at the time had a network, an alert system of advances of one type of weed, that was working very well. At that time, every 3 days, I went to the SENASA and I was checking the advance of that species. Honestly, I thought that that was going to be the case, that SENASA would do an alert of Johnson grass alert, but nothing of the sort happened. They never disseminated that information. I did not feel authorized to disseminate this because I was a mere producer. But that brought about that SENASA truck. A vet comes to pick up the plant. So imagine how well prepared we were. So as from 2007, and since I was stirring some things at Aapresid, we had the first wheat panel. And of course, we have Tuesca there, president of the Congress. Silvia Pasalacqua was in charge of SENASA. The Resistant Plague Commission, I joined as an Aapresid representative, a person that was working for Monsanto, and a Salta producer. In Salta, they already had more problems because they started with problems earlier on. And so I joined the Commission of Plagues as of the next year. What happens the next year? and I thought that we had to do something because it was really severe. I started with Echinocloa colonna in a plot. I thought the product had been washed away, but then I started seeing this in other plots in separated areas, and they did not die because of the glyphosate. I called Sylvia, that was in charge of resistant weeds. I have a Echinocloa resistant problem. Yes, Pablo, they are studying at INTA Olivero and other universities. They are studying because there's a type of Echinocloa resistant. So I had the dose response curve. It takes a couple of years. And the question that comes up is, why did not alert? Why didn't you raise a flag? Because you have to announce that this resistant biotype. And this motivated me to say, this is a task on the producer, because you have to look up the paper, because that's the role of an investigator. But the producer has another problem, because when 2 to 3 years can go by before we have results from a research, and in 2-3 years there could be disastrous consequences on a plot. So that motivated on the 2010 to found the REM. What was the idea of this network? Very briefly, was to disseminate or to raise red flags, alert and dissemination of the problems. We was going to give talks to technicians, to AFA technicians. We work a lot with them, with sponsors who took up this topic, who started giving economic support, universities and the INTA. We wanted the INTA, the National Agricultural Technology Institute, to give the okay. But in the meantime, we raised a yellow flag. So we started disseminating problems. We give an alert. And thus, these were the years from 2007 to 2019. I thought we were having a big problem because we have resistant and tolerant weeds. And this network is developed, and we started working in a coordinated manner, collecting information with the research groups. We have this problem. This was very good because we did not have it in the past. This is a network of researchers who conducted the research works, and scanning this QR code, you can have more information on these papers. Daniel is part of many of the research works, and the articulation work we did with science was very, very fruitful. Following with the timeline, in 2013, we founded the Chacra Bandera, a field with a lot of resistant pests and weeds. We thought we were not doing things right. So we started studying the cycle of weeds, the different chemical groups. Especially, we started studying the suppression of weed with certain crops. We knew herbicides was not going to be enough, so we disseminated a lot of information of chacra in terms of service crops and the weed suppression. This chacra continues being under development. We solved many questions and many problems on wheat. Thanks to the research, they do not have any problems with wheat. And although the Chacra Bandera still works on other agricultural topics, the Chacra Bandera is working very well, and they have eradicated certain species. Last year, I realized, as Jose Luis said, that I had a Marantus palmeri problem with a recently rented plot, and this experience, I made I reported the situation, and in February we collected the seeds. In August, the response dose was ready with concrete results, and we knew it was a resistant rate to sulfentrazone. And this is very important because we had a prompt dissemination, and the next year they conducted a research work from different groups. I offered my plot so that they could conduct the research work. So during a season, we did not only knew the resistant biotype, we knew the response dose, and we generated information to solve the problem. This is the acceleration of what we did. What used to take years, we did in less than a year. It was a super achievement for the network. And some negative aspect is that although, in spite of everything it happened, in spite of all the time we devoted with researches, different works conducted, many people disbelieve. You are creating alarm, they used to say in the social media. It was really surprising that people really disbelieve in science, because this is pure science. So this is some of the conclusions I wanted to share with you. And now to wrap up, this is a very emblematic slide. It was presented by Ian Heap. To me, Ian Heap is, I look at him as a producer, not only a scientist. He is the top authority in herbicide-resistant wheat. He collected all the information, world information. He loved he came to the Congress, he loved the REM system, and he gave us this slide. I'm going to explain. It says every practice that has to control weed year after year will result in an indirect evolution through survivals. The solution is to vary different practices of weed control and destabilize evolution. What do we have here? A rice plant. And here we have echinocloa plant. This is in India that they harvest by hand. They plug it out by hand. What does the echinocloa does? This in the middle is an echinocloa plant that evolved so that the seedling becomes a sort of rice plant, so they cannot remove it. So the seedling became resistant to manual plucking. So I thought it was fantastic because it was not a problem of a magical tool, a magical herbicide. But if we do not destabilize the evolution of weeds, weeds will always win us over. So this was my idea. This is a wrap.
Pablo, muchísimas gracias. Bueno, vamos a pasar al siguiente de los oradores del panel, que es el profe Daniel Tuesca, biólogo.
I give you a biologist, the tenure professor from the University of Rosario, and an independent researcher. His task is biology and weed-resistant and herbicide-resistant weeds. You have the QR code there. You can scan it to ask questions to the panelists, and at the end we will have a panel where we can ask the different questions to the speakers. Daniel, the floor is yours. That round of applause was for him or for me? Good morning, everyone. First and foremost, thank you very much to REM for inviting us to participate in this panel as a celebration for the 15th anniversary. I love the presentation. I like Pablo's presentation very much. As you see, we're going to see nice things of one another because we are all friends here. So my talk is 30 years with resistant weeds in Argentina. And the question is, have we learned anything or have we learned something? It's a challenging question, and that's the idea of this presentation. Most of you know what this is, but I can't help it. I'm going to give the definition of resistance that is not the same as tolerance. And we speak about resistance when we speak about the inheritable capacity of a population of biotype to survive and reproduce itself after the application of a herbicide dose that used to be lethal for the originary species. That is related to the evolution Pablo spoke about. And I'm going to make reference to genetic variability and selection. Why is herbicide resistance important? Because we require changes in weed and crops management. We increase costs, our cost gets increased, and there are losses in yield and profitability. And one that is the most serious, at least to me, is that the solutions or tool spectrum starts narrowing down. Pablo mentioned something about it. This is the timeline as to when the different ways of herbicide action start appearing. And as you can see, it starts in 1950s and it gets to 2020, 2030 in the future. Most of the herbicides we are using have been developed in the 70s, 80s, and 90s. That's to say, there are no new action modes. There are new herbicides with all formulas or all modes of action. So it's something modified. There is a new action mode. It's like a Falcon. Most of you do not know what that car model is. It's an old, a vintage car. So in 2020, we see a new mode of action, but it's not representative. When you see this, we see that modes of action are a limited resource and very little renewable, at least as of now. And this should raise a red flag. Although there are many companies here that are present at the Congress who are presenting new herbicides, if you look at the technical newsletter, is the same modes of action. So this is something to be taken into account. How is weed resistant to herbicide gets originated? The first thing we need is genetic variability and then selection pressure. Genetic variability is already there, and what we do, and we do very well, is to push for that variability to manifest itself. So that gives us a result, biotypes or plants or groups of plants that are resistant. This is the REM curve. I want to show what Pablo showed, the appearance of the first biotype of resistant weed. In this case, it was Amaranthus quitensis. Then they changed the name, I think. I'm not going to say. Taxonomers Congress start collecting information and they give new names. But to us, that was Amaranthus quitensis, and that changed the name now. This is 1996, 1997. It simultaneously appeared in the northwest of Argentina and also in Marco Juarez and the central areas of Argentina. And this is one of the first experiments we conducted with response dose analysis. And for you to have an idea, this is to the left, you see the plant with no herbicide, and the extreme right is 64 liters per hectare. The use dose is 1 liter because basically we use it to control Cipidus, but the susceptible biotype was controlled with 100 cubic centimeters. So we are increasing dose 10 times to kill the weeds, but that implies a a very strong selection pressure. I cannot go back, so do you understand? It's not a class I cannot go back, so say yes. When we look at the selection scenario of that resistant biotype or susceptible biotype that we used to compare, the resistant biotype is the one from Marco Juarez, which is in red, and the biotype that we use as susceptible was from the experimental university field in Savaja, where we did a crop rotation, wheat and soybean, and we used imacetapir 1 year, atrazine, another one, bentazone. However, in Marco Suarez, where it was resistant, the 5 previous years they have used only imacetapir. This implies a lot of selection pressure. In any case, as Pablo mentioned, that resistant wheat appeared, and they organized congresses, and we had not a lot of success, 10, 15 people. Although it was the pig wheat was a serious problem, it didn't seem to be an agenda. But it was the case that RR technology appeared, so wheat stopped being a problem for some time. Those acquainted with biology suppose that at a certain point that was going to revert, or to backlash. We think that we can handle nature, but the truth is we do not. And the direct seeding or no-till system was widespread, so we use very well most of wheats with glyphosate. But if you analyze the evolution of the glyphosate market in Argentina, we came from very high prices to very low prices of glyphosate. This makes us use a lot of glyphosate. This is the evolution of the glyphosate market in millions of liters. We went from 20 million liters to 200 million liters, and this is the evolution of the price of glyphosate in Argentina. What did this imply? The evolution of the crop surface tolerant to transgenic. 98% of the soy we produced was glyphosate tolerant, also corn and wheat. This is the share of herbicide fallow in 2005. 92% was glyphosate.
But the problem was not how much glyphosate was used, even though a lot of glyphosate was used. The problem was how we used that glyphosate. And here I would like to connect it with what Pablo was saying with regard to Monsanto's claim back then. Monsanto used to say that glyphosate-resistant weeds were very unlikely to appear. And I remember that these were elegant scientific papers where speculations were made as to why it was so difficult that resistant weeds would appear. But never did anyone consider how glyphosate would be used, the selection pressure that we would exercise through glyphosate. We would run surveys, take a look at 2001, for example, and we would ask what other herbicides were used apart from glyphosate in 2001, and up to 16 different herbicides were named for fallow across surveys, 16 different herbicides, and in soybean up to 13 different herbicides. When we redid this survey in 2005 for fallow, they said that apart from glyphosate, they just used metsulfuron, 2,4-D, and atrazine, and for soybean, just glyphosate across the board. Of course, this implies a huge selection pressure for tolerant or resistant weeds for glyphosate. So what happens? Pablo said this. A sorghum alapense biotype appeared in 2005, which was of course, resistant to glyphosate. What other thing to expect? And there, take a look at the wheat experts. The wheat experts as rock stars. You would organize a seminar, a conference in Aapresid, and there was a huge turnout of people who wanted to learn about resistant weeds because the problem was sorghum alapense and glyphosate. In 2010, REM was created, this network for pest management. If I asked you from 2010 onwards how this resistant biotype curve increases, what would the conclusion be? It's the fault of the REM network, isn't it? I mean, if you present this in China or in France, you would say, well, what happened there? Well, this network was created in 2010, and take a look at how the curve skyrocketed. But no, of course. And this is connected with what we were asked to prepare on the REM network. The REM network was created at a very timely point in time because there were just 3 resistant biotypes, and we started to work on this, and we started to work on the problem itself. So the REM was an articulation space, and it continues to be an articulation space between researchers, technicians, and farmers who were isolated in the past. We were working solo, and there was no entity bringing us together. REM continues to do a very good job of bringing people together because it has built channels for communication channels and so on, and it has been very efficient in gathering, processing, and conveying information. And more importantly, it has positioned weed resistance in the public agenda. This was seen in the various congresses. And this is how does communication become effective, thanks to the REM network with these types of graphs. For example, we have shown these graphs over and over again in national congresses, in classes, in lessons, also with brochures on the biology of weeds. This is very important because we insist in controlling weeds and managing them as well. To manage the weeds, we need to be aware and cognizant of the biology of each weed. Another interesting thing is the maps showing where the problem lies, and the alerts and the red flags. And it's not that I like the yellow flags more, but I think that the yellow flags are very important and useful because it's the beginning of the alert. The red flag is, well, the problem is already there. But the yellow flag is like telling you, well, be careful because there's a problem here. So I'm coming back to the same graph, and here I say I need to have genetic variability so as to prevent resistance from appearing. So do I need to have genetic variability, or do I have to wait for it? Of course, I do not expect for you to read all of this information. These are screening experiments or population evaluation for different weeds that were carried out by different groups of researchers together with HRAC, and this has to do with putting to the test 50 populations of Amaranthus hybridus vis-a-vis different herbicides, different doses as well. Also, all the boxes in orange and red mean that this population is resistant to that herbicide. As you can see, there's red all over the place right here. So, well, these are the herbicides: 2,4-D, dicamba, fomis, glyphosate, and trimexone. And the same was done for Coniza, with some populations of Coniza, and all of the things that you can see in these Coniza populations right here in the left: 2,4-D, dicamba, diclosulam, glyphosate, etc. What you see in orange and red is resistant varieties. And this paper, written by Yannicari and Gigon, everything in red and orange are ryegrass populations that are resistant to those herbicides. Take a look at the population number 14. It's resistant across the board. So why am I showing you this? Genetic variability is already here. We do not have to wait for it anymore. It is already here. The only thing is that its frequency is low. But what are we going to do? Well, if we do things poorly and we apply a lot of selection pressure, all of this will become a problem for farming. Is this clear? Well, why, despite having so much information on resistant weeds, this is my own personal opinion, why is it that we are not seeing encouraging results in spite of having so much information? If we draw a graph of the curve of information generation, the curve would look like this. But if we analyze the adoption curve, that is the adoption of all of the information that we have, the curve is not the same. It is way below. And I would like for us to work on the reasons for not using this profuse information that we have. The response is not easy, but I think that it is very interesting as food for thought. And I think that the difficulty for efficient management of weeds in general, not only the resistant ones, lies in the farming model that we have. So this merits a whole Congress. Resistant weeds are not a challenge for farming. Rather, they are a challenge for the way in which we farm. If we do not understand this, I think that we will still make mistakes. And as I said at the beginning, as we do not have new tools, the problem is going to become more and more serious. Is it possible to manage resistance just with herbicides? I think it would not be rational to do this. I am actually convinced that it wouldn't be rational to do so. It wouldn't be sensible. Poor use creates new and bigger problems, and the associated risk is that some herbicides, or most of them, which are really good, end up proving useless for lots of situations. So this was mentioned by Pablo as well. New technologies are about to arrive, like 2,4-D tolerant soybean and corn. In a few years, we are going to see HPPD tolerant soybean or PPO tolerant soybean. So is this going to be a solution? Will they be a complement, or will they increase the problem? Will they exacerbate the problem? I think the answer is it depends. It will depend in the way that we use these seeds. Of course, they are good, but we may destroy them in just a very short time. Risks in the near future. An increase in the distribution and density of annual grasses. Actually, panels on grasses were held yesterday on Brassicacia, that is Brassica. For us in the area of Rosario, we didn't have a lot of problems with Brassica, but now we are having an increasing problem. An increase in the cases of resistance to graminicides for these grasses that I just mentioned. An increase in the cases of resistance to growth regulators because people are using the new technologies way too much. This is something that was of course going to come. The increase of resistance to PPO inhibitors, using it too much creates resistance, and also an increase in the cases of multiple resistance. So have we learned anything? Well, yes, I think we have. I think we have learned a lot. We need to narrow the gap between information and information adoption. Some traits of the current farming model cannot be modified. It's something that is beyond us. But there are other practices that we can modify. We do need to reduce selection pressure. We do need to increase the number and the quality of signals that we send out to weeds. Weeds are highly variable because they have a lot of genetic variability, and we don't. We are not variable when it comes to our management. We always talk about chemical control, and chemical control entails a very small management variability, and we need to talk more about management and less about control. And this is the last slide. We say that we are doing integrated weed management. We do a lot of chemical management. We do a little cultural management, but sometimes it's almost unwittingly, and a little bit of mechanical control. I think that in the near future, we should, rather than reducing the chemical control, I think that the chemical control pie needs to become more efficient and more rational. Surely mechanical control will come up with new approaches. Mechanical control is not just about tilling the soil using a cultivator. There are seed destroyers, there are other tools, and what needs to become more significant is the cultural control, whether it be through the use of more competitive crop genotypes, more rotation, working on density, on intercultures, etc. So that we need to have more management and more integrated management as well. Thank you. Thank you, Daniel. We are going to move on to the third participant in the panel, Daniel Ploper. Daniel is an agronomist. He has a postgraduate degree in pathophysiology in the United States. He has also engaged on PhD degrees in Auburn in the University of Alabama in 1990. He worked as a technician in pathophysiology in Obispo Colombres. It's an experimental station in the Northwest. Between 2004 and 2024, he was the director of this institution, and starting 2025, he continued to work for this station as a researcher emeritus. He is also a teacher at postgraduate studies in the Veterinary University of the University of Tucumán, and he's a specialist in pathophysiology. He's the director, co-director, and a jury member for PhD dissertations. He has received lots of awards nationally and internationally on account of his work as a scientist and an academic. Daniel, you have the floor. Can we hear you? Can you hear me? Thank you. I would like to express my gratitude to REM. Thank you for giving me this opportunity to come over and sharing topics that do not have the same history as weeds, but which we need to learn about. And it's like a yellow flag at this point because resistance is beginning to appear for fungi, fungicide resistance across a number of fungi. As Jose Luis said, I still work for the Obispo Colombres experimental station. You know it, many of you know it. This is the oldest experimental station in the country. Its model is very peculiar because it is economically supported by farmers, and it is also steered or directed by this very same sector. When this station was created, when it was founded in 1909, the goal was working out farming problems in the province, especially for sugarcane crops. And over the past 116 years, a number of instances have taken place where the station had to step in so as to put the brakes to epiphyteous plants such as the mosaic disease of the sugarcane, the sugarcane smut in the 1940s, and also citrus diseases in the 50s, virus diseases for beans, also like, for example, the branch spot, and also problems having to do with corn in recent years, stunted growth for corn. And why is that? Because diseases are significant factors that restrain production. In recent years, we've seen losses of up to 100% in soybean plots because of branch diseases and also spot diseases on the leaves. So because of that, we need to intervene through disease management, through genetic control strategies. If only we had the resistance where, as we can see right here, black and white in the case of the toad eye spot. Techniques such as cultural control can be used, spacing, seeding density, or for example, putting the stubble way underground. This was the ancient recommendation. Of course, we cannot say this right here, but for necrotropic pathogens, it's a way of reducing pressure. So through chemical control, this is an efficient practice. It is economically viable, it is fast, and we also have alternatives having to do with biological control through the use of antagonists. So right now, let's talk about fungicide resistance for fungi. So what are the most important AIs that are used for disease control? So we have the group of MBCs, methylbenzimidazole carbamates. We have benzimidazoles and thiophanates. We have demethylation inhibitors, DMIs, like triazoles, QOLs, like strobilurins, and the inhibitors of dehydrogenase succinate. These are carboxymides, SDHIs. So these groups are site-specific because they act on one single place versus multi-site fungicides, such fungicides that act on multiple sites of the plant. And the risks for resistance to fungicides lie with the first four groups that we can see on the slide. Some of them are preventive fungicides, such as strobilurins, carboxamide, multi-site fungicides. These have a protective effect. They prevent the penetration of the fungus into the plant. There are others that are curative, such as benzimidazole, triazoles. These act once the fungus is inside the plant. The later the action of the fungicide, the less successful it will be. Let us take the case of soybeans. This was mentioned before. Take a look at the graph. This is the area planted with soybean since the 1960s up until the present day. And the big turning point happened right here in the mid-1990s, 1996, 1997, with the advent of the first RR soybeans, or glyphosate-resistant soybeans, in combination with no-till, and the drop in the price of glyphosate. So what did this mean in pathological terms? In many cases, a monoculture of soybean and its ease of management, especially in the north of Argentina, this also entailed more inoculation, more stubble, more necrotrophic pathogen inoculation.
And we started using more frequently due to the presence of these diseases. We started using more fungicide, as I said, in the north of Argentina, because we started seeing a response in the yields to the application of this fungicide. In 2023-2024, 73% of the crops received at least one dose, or in 15% two doses. So there were years that, due to economic or environmental reasons, that we apply more amount of fungicide, up to 98%. And we used double dose or double mixes of fungicide. As we started using more and more fungicide, we started seeing control failures. For example, in the north of Salta, with in soybean, we saw leaf blights. And we started putting the blame on the product. But why can these fungicide fail? One of the things, it could be the change of doses, to use subdoses or to divide doses in different in separate applications. Active ingredients that are not efficient enough for the diseases one would to control. Late applications, after a certain threshold, we arrive late with the product. Or we use technology that is not efficient enough, or dated products, poor environmental conditions for the application of this product, or the appearance of strains that are less sensitive to fungicide. And out of all these causes, perhaps the last one is the most difficult to identify. We saw that it started moving forward, that this insensibility started advancing. It should not be too striking, because the resistance to fungi to fungicide are very well known. In the case of benzimidazole in the decades of the 1973, triazole since 1981, estrobilin since 1988. In certain labs, they said it was they were resistant to these. So how can we confirm these resistance and do away with or rule out all other reasons? There are certain strict protocols we have to follow to identify the problem first. Then we conduct sampling and isolation. We have to conduct the right identification, morphological and molecular identification of the pathogen agent, and then the gradient trials of fungi concentration. Once we have all that information, we have in vitro test, and we end up with the molecular sequencing to confirm certain mutations or other mechanisms that are bringing about this resistance. And last, the paper publication that is for the dissemination and the peer review in important scientific journals. Once we conduct this procedure, we start disseminating the information and recommendations as to weed management or fungi management. These are gradient trials with fungicide concentration, the effect of methyl thiophanate on 3 isolations. As you can see, this is to apply whether the product is inefficient, moderately efficient, or highly efficient, according to the concentration of the effective concentration, the 50 in 50. And here we have for carbendazim, this part per million, the fungi continue growing up to 50,000 parts per million. This is to show that fungicide can resist. The fungi is resistant to fungicide. As of then, we started developing several studies for different crops with different pathogen agents. This is a list of different resistance. For example, for Cercospora kikuchi, there's resistance to carbendazim, stribilin, cyclopronazole, carboxamide does nothing to this fungi. In the case of rust, there's no resistance reported in our country. In Brazil, there's a resistance to triazoles and carboxamide. In Argentina, we did not have the necessary selection pressure because there's been very little pressure of the disease, and consequently, there was no resistant generation. For brown spot, they reported resistance to strobilurin. There's also resistance to strobilurin, and since we did not conduct the molecular sequencing, we cannot confirm. But everything seems to confirm that we have this resistance. The same goes for wheat. And in the case of yellow spots, there's a resistance also to cipropanazole. We have a reduction, sensitivity reduction, and also for barley, citrus, perhaps the oldest one, is resistance to post-harvest fungi. So without reaching the alarming situation, and in the case of wheat, there's already enough selection pressure of certain diseases to generate these variants. What do we need to do so as not to have these problems of resistance to fungicide? Just as in the case of weeds, there's genetic variability, there's mutation at a rate 1 to 6, 1 to 7. When that mutation happens in a certain site that is related to interaction with the fungicide, then we are in the presence of a mutant variant. They tend to be naturally in nature, they exist. But when we start applying the fungicide, just as with the herbicide, they start selecting those species and they start proliferating. So what can we do to replace what's unavoidable? Because resistance will appear because it exists in nature, and the more we apply, the more probability we have for it to appear. So what can we do? So as preventive practice, we can do crop rotation, control of certain species, resistant varieties, or use the one that best perform with under this disease. And we have to detect as fast as possible when there's a resistance, to establish the baselines, to understand the performance of the predominant population, predominant pathogen population, which is a variable population, where there is a low proportion of resistant population. As we intensify the selection process, the higher the probability to see resistance. So this is what we can do in a preventive fashion. From the program point of view of fungicide treatments, we have to follow these recommendations to use a fungicide that is recorded at SENASA, to use treatments that are really useful, not to apply unnecessary fungicide, to ensure fungicide rotation, use a mix of fungicide with different action modes, to avoid the individual use of fungicide that are site-specific or monocyte, to add this multi-site fungicide because they bring about very good results with chlorine. We should not apply subdoses of fungicide. This is particularly important because if you use a subdoses, you start generating a higher stress in the pathogen population. Sometimes you do not fully kill it, but that higher stress stimulates mutations, facilitating the appearance of new mutants. So you should never apply subdoses. When there are environmentally prone conditions, you have to apply fungicide preemptively. You have to wet the plant well and respect the protection periods of fungicides. These guidelines are very clear for the REM. And what is the great value of this network? In the dissemination of information, the alerts they spread, and the follow-up they conduct, with the additional benefit that it's an organization where the productive sector is present and it is connected to research institutions. So this allow a better reach to the productive sector. They also conduct monitoring and diagnosis of cases and raise awareness on all these problems. Also, as product of the REM, I want to highlight the value of pest and diseases maps, and also the field days with different advisors and specialists. Another channel of communication is our podcast, health in soybean, fungicide sensitivity, etc. I want to highlight that this type of guideline, in order to delay resistance, the appearance of resistant strains, there's a fungicide resistant action committee that is made up of the different producing companies that research these phytosanitary products, that was created in Europe in 1981 and in Argentina since 2016. And you will find in their website valuable information. I would like also to mention that there is a commission of studies on fungicide in Argentina that is made up of scientists and technicians who work on these problems, and their goal is not only to share and disseminate information, but also to concentrate information on fungicide that is being generated in information through scientific papers or postgraduate thesis. And very soon they are going to find all the papers available that are being developed on fungicide. They will be uploaded to their website. There's a mail there. You can consult via that email address. To conclude, in the case of diseases, the problem is not as important as it was with weeds, but this is something that we have to be very careful about, because we have to learn from all the past lessons. We have to correctly identify the problem, rule out the other causes, and once we have a suspicion, we have to run all the right protocol to get to the right conclusion that there is a resistance or not. We have to take care of technologies like in the case of herbicide, there are not very new fungicides. So every time we have a product, we have to take good care of it, because otherwise it becomes totally inefficient if you overuse it. You have to continue training the productive sector. The farming sector has to continue their training. And perhaps the most important thing is to follow these recommendations. We do not provide these recommendations just because. It is targeted to the delaying of the resistance. Resistance is inevitable. What we can do through our practice is to try to delay its appearance as much as possible. Thank you very much for your attention.
Daniel, muchísimas gracias.
Thank you very much. Now, let's go to the fourth and last panelist, the farming engineer Roberto Peralta. He's a specialist in vegetal protection. He has a master's degree from the University of Litoral. He's a tenure professor and associate professor of the Catholic University of Córdoba, and since 2003 he devotes to plague management, providing ongoing training through MOA, he's the CEO manager of this consulting firm. He has participated of research and development of pest projects, and he's the co-author of many books and research works. Beto, the floor is yours.
Good morning. Thank you to the people at Aapresid who invited me at the beginning when Jose introduced me. He asked me what I do. What I do is I monitor plots. After teaching classes and being a teacher, playing with research was fun for me. So I have been monitoring plots for the past 25 years. So I provide recommendations. I'm sort of a consultant. Everyone thinks I'm an entomologist, but I'm not an entomologist. So I'm a plant health consultant. So right now I'm going to talk about the current situation of pest resistance. It's very difficult to talk about pests, and I was asked to talk about weeds and diseases. And when I talk about pests, there is a difficult part and a hard part and an easy part. Pathophysiologists said that phytopathologists have a very tough job to carry out, like, for example, checking on a spore and so on. Now, for example, if you're working on weeds, weeds are very clear. You cannot lie about weeds. And why do I extrapolate this to everyday life? Because this is what everyone does. If we take a look where myths originate in the sector, myths originate there where we cannot see them. There are myths that have to do even with herbicides. For example, there is more of a myth, or there are more myths with pre-emerging herbicides than with post-emergence herbicides, because it's about the things that we cannot see. So let's talk about some concepts that are mentioned in scientific or technical publications. These are dictionary definitions for recurrent, emerging, and occasional. What is recurrent? Caterpillars, Lepidoptera, for example. Emerging or emergent, that is to say, these are new things. Emerging is something for the pampas, for example. We have the case of the maize leafhopper. Leafhoppers were known in the past, but not so much. They were not so difficult. Like, for example, this black bug that we can see right here, and then we have occasional pests, like the ones that appear all of a sudden, and they do not appear ever again. But we need to take a look at this, because management is about rotation. It's about everything that we do over the years. The economy determines what crop to devote yourself to, and the rotation. So this will determine how the problems are going to appear. Later problems appear after the management that we propose. There is one single bibliographic quotation about pests originating spontaneously, and those were the locusts in the Bible. That was it. So we always need to find an explanation, because there is always a reason for pests that appear. So with regard to evolution, it's the same for insects and for weeds and so on. And if we take a look at the evolution over time, 1914 was the case of a resistance for a ladybug, and then there was a BT technology that was created, and it was used a little bit later down the road. So there's a whole management thing going on. There are interesting publications, and it is here that we are dealing with Argentina. This is a very interesting website which records all the resistance cases published worldwide, officially and non-officially, and you can make a selection. You sort of filter by country and so on. So these are cases of resistance for Argentina. So you have meds, such for example mosquito resistance or agricultural resistance. And what has been quoted for Argentina are transgenic events. So there are a few quotes for chemical events such as organophosphorates, and so on. So why am I mentioning this? Because what really finds an echo is what is published. So are we acting reactively or proactively with pest resistance? We have been mentioning the RACs. These are the resistance committees because we have the HRAC, IRAC, and FRAC. If we take a look at when these happened, HRAC was created in 2015, same for IRAC, and the next year FRAC was created. Nationally, internationally, we have insecticide committees that were created first in the 1980s and followed by fungicide ones. So in the case when what Tuesca showed is crucial, because in the past, for example, people would flood the rooms of weed discussions after the problems with glyphosate emerged and not before. So, well, we want to see how this was adjusted, and, well, sometimes we are in a pickle because we do not know how to communicate things. Sinavimo, what is that? This is the SENASA network. This is the health surveillance system, and they can only publish what has been certified, not suspicions, not suspected pests. For example, if we deal with pests, for example, Diatraea and Spodoptera, and these are cases that have to do with BT resistance. So officially, if a foreigner wants to know what is going on in Argentina, he takes a look at this SENASA website. It's an official website. It belongs to the government. And this is what he will find. Just this. And Pablo mentioned this, and I will repeat this. This is interesting. This was mentioned by a lawyer, actually. I am a monitor specialist. I try to understand in order to make decisions. This was mentioned by a German jurist, Rudolf von Jhering. He said, the fact comes before the law. What does that mean? Facts come before the law. This means that pests do not wait for the paper to be published to become resistant. So if you take a look at pests, I interact with pests. It's really amazing because pests have lots of things to say to us. You want to control the pests, you want to do applications, you want to control their evolution, but they are always one step ahead of you if you do not understand their evolutionary process. So this pest resistance needs to be understood as a process over time. So for pests, it's the same. It applies to herbicides, it applies to fungicides, it's selection pressure. And there are lots of myths and there are lots of beliefs. For example, today it's really fashionable, and I know I will be politically incorrect here. For example, bio-agriculture is so in, like, for example, if you write bio for a product, you sell straight away. There are bio inputs and bio pesticides, no resistance generated. No, that's not true. Biology always will adapt and resistance will happen, no matter if your product is bio or not, and organic. And this is sometimes confused with resurgence or reemergence of a pest. This is slightly different from weeds or fungi, because sometimes the population dynamic explodes and there are supposedly control failures which are masked as cases of resistance. So as part of the REM network, we decided to find what we are researching and what is happening on the farm. So where can the problem lie? When you do successive applications of total products, those that really miss chlorpyrifos, well, that is what it did. It was the molecule against re-emergence. So, for example, in my province, before other products, pyrethroids were used a lot and organophosphorates were used quite profusely. So I'm sure that it was amazing how much phosphorus we used. Well, there was no single natural enemy that was left, and well, this is quite common as well. What is important with these organizations is to have guidelines, having a framework as to where we are standing. For example, these reports are not biblical things. This is not written in stone. These are guidelines for a better understanding. And, well, they are about rotation principles. You always do rotation with AIs and mode of action, but the principles need to have to do with modes of control. That is to say, how can you win over nature? Because there is nothing more artificial than farming. This is the most artificial thing created by humans 10,000 years ago. So we need to manage this appropriately. Like, for example, in the case of Spodoptera frugiperda, one of the biggest problems we have with maize or with corn is BT technology. There is something with corn that it broadened its frontiers, this especially towards the north. And we can see in the north of Córdoba there are 3 generations of corn. There is an early seeding season. The biggest problem happens with the first generation because this coincides with B3 and V6. This is the worst moment in which the Spodoptera can attack the corn. Now, if you seed it later on, then it will be exposed to the 3rd generation. So if you change the seeding season, you will change your management as well as the pressure on the system. So a lot of progress has been made with the late season corn. And this allows you to see, to change system management depending on the regions. We have been able to understand the different regions where we are standing. These are the eco-regions. This is a map by the National Parks Agency. I work in the north of Córdoba. This is the same region as the region of Tucumán, Santiago. This is a very large eco-region. Now, for example, people say we have this new bug in the province of Córdoba, and they say, okay, there is this problem of this bug in Córdoba. So remember that it depends on the consequences, and we have a lot more cases of examples. Like, for example, with Helicoverpa, we all know that there is a resistance to soybeans. But there is nothing that has been published. So that is what I mean. One of the problems that will be caused by this, and I'm really concerned by this one much more than the fall armyworm, is because it's producing a lot of damage and it also modifies the entire system. And this was the best thing that we could find to improve yield and trying to make this or to adapt this to the rainfall so as to make the corn more stable. And And it's not just what it does right there, but it also coincides with the floods or the heavy rainfall in autumn. And, well, you can see that there are two fungi right there, Aspergillus and Penicillium. So right now, the industry is going to ask us to be really careful, and we need to think about the entire system. And if you're going to mention the leaf hopper, of course, I love this bug. It's just amazing, because one of the problems that we had in the academia is that it didn't have, there was no interaction between the different experts. So the phytologists were on one side, the pathologists or the entomologists were working differently. But thanks to this bug, all the experts were brought together, and it grows just on the corn, and the same for wild corn. So we need to talk about integrated management. So this has been very harmful in two campaigns. The prior campaign, it was very, very harmful. And it's like a toxic person, that is very harmful. These people that are always harmful, no matter if they are not in the room. So we managed the seeding season thinking about this bug, the maize leaf hopper. So the problem is that we are always behaving in the same way. We are always exercising chemical control. Why do we do that? It's a human thing. People go to the doctor, and what do they say? Give me a pill. The doctor tells you, no, but you'd better go on a diet. No, I want the pill. So everyone wants the easy way out, the chemical solution. So, for example, in the case of the leaf hopper, it was all about chemical control. And when we held a workshop, 90% of the issue was about chemical control. And there were many specialists in the room. And if I take a look at field applications with an insecticide, because it's economically justified, selection pressure is just huge. And Brazil already has resistance for this bug in some products. So if we do not recognize that it's a human problem rather than a pest problem, we will continue to have the same problem. So let me talk about the challenges that I see ahead. I can see that there will be evolution for technology and evolution for behavior, but this is the evolution that technology and human behavior had over the centuries. So we need to ask ourselves how we behave vis-a-vis technology, facing technology. One big challenge that we have nowadays is this one. Right now, there is a new interaction with technology. So there is a huge turning point for our behavior with regard to technology, but these are just first days, and we will then see that there is growing resistance. So AI is just amazing, it's fabulous. I am interacting a lot with AI, more than what's normal. My wife says that I'm sick in the head because I have arguments with AI, and I do not want to have arguments with AI because AI always wins. But I do suggest that you explore AI, especially because the new generations, they need to be educated. A sociologist used to say that education was one generation trying to teach another generation for life. But this is what is said. People that come over with AI, if I do not share a number of guidelines to manage this, that can call a collision that is unnecessary at the end of the day. So today, as adults, we need to talk with the new generations and explain to them how to manage this. So nature moves on, and we need to know where we are standing. A number of years ago, I created this graph because when you see something that is fascinating for you, you need to pay attention to it. For example, these are the topics for Aapresid dissertations or Aapresid presentations in 2022. You can see the pie chart right here. So with regard to plant health, there were a lot of presentations on weeds. So this is so difficult for humans, right? So when I take a look at this reality, I think that this is the value of our REM network and of all networks for that matter. On a daily basis, we are talking about selection of topics. The selection pressure that we exercise on the system when something becomes resistance, well, REM, all of this daily information, you need to be there all the time saying, okay, if we don't do this, the system may have these failures. So this is the idea, and this is a statement by evolution expert. This has to do with microevolutions, actually. And this is a biologist, Stephen Jay Gould. He was actually a paleontologist, and I really love his statement. He says, humans are not the end result of predictable evolutionary progress, but rather a fortuitous cosmic afterthought, a tiny little twig on the enormously arborescent bush of life. And here we can see the staircase. You can see the evolution from the bacterium and the guy at the top. So we are not the end of anything. If we do not understand these interactions with nature, we will continue to bump our heads against the wall. After a long period, that is what will happen. So this is what arrogance is, and there is no other explanation for humans. Thank you.
Grande, Beto. Muchísimas gracias.
Thank you, Beto.
Bueno, llegamos al final del panel.
This is the end of today's panel. We have very little time for questions, but before we have the stools ready for the panels, do not rush. You're all invited to a toast going up the stairs. EY room, there will be a toast. We have to finish at 1, but we're going to take 10 more minutes so as to have a Q&A section with different speakers. You all agree that variability exists. You've seen this in the specialties, and that we all act according to the selection pressure. They all mention that there is an adoption rate that brings about consequences to reality. Many of the reasons are related to the productive models we have in our country. And sometimes we have a lower adoption than we should have. If we are ready, and one thing that remained is that the press, when we are pressed for time, results are not the same. So sometimes we have to act faster. I will ask the first question. I think I'm going to ask one question per panelist. Daniel, you mentioned that the action mode are limited resource and not renewable, and many companies are editing molecules through AI, and the timing has shortened. Do you think that will change with weed management? It depends. There has a positive aspect. we are sorting out problems that are already there, but it's a short-term view. We have to shorten the terms to have new solutions within the chemical control pie. We are not thinking of anything else. I think this is the biggest mistake. Since we are only thinking of a small pie, I think it's an advantage. The disadvantage is it's very good. We are going to destroy it very fast because we are very good at that. We are very good at precisely. The motto is if it works, change it. That is to say, rotate it, use other things. But we have the tendency to overuse it if it works, even when we should not use it. So herbicides are not magical. Herbicides are not magical. Due to a question of need, we attribute herbicides things that are not even part of their action plan, the action. We use it in specific weeds many times. We are selecting through low doses. If we apply subdoses, if we use a dose to wide weed, the weed takes it as a subdoses, and there are many resistant mechanisms that are selected via subdoses. So it is a solution. They are welcome, but I think we have to broaden the spectrum as to how we look at the ecosystem. Beto, I attended one of the presentations yesterday, and a biotechnological event takes 13 years, and it demands $136 million. Did you expect for the events that you showed for wheat and soybean to rotate so fast? Ever since we started DBT, did you expect for it to be so fast? Yes. Seeing the way we handled it, I could not risk timing because it depends on the genic frequency. That's the big question. Without that piece of data, you cannot tell how long. But according to the management we had, the selection pressure for BT technology is 1,000 higher than the chemical pressure because it's a presence of the toxin at every time of day. So it's a total pressure. So you are not applying that all day long, exposing it to the molecule. So the pressure is very heavy. So it's something biological because protein comes from something biological. It's not something xenobiotic. In this was in nature, so it was to be expected. And I think we have the first events became with Atraeno, but it was another herbicide that was the winner. And sometimes biology does that, but when you see the management, that was to be expected. Pablo, Daniel saw a gap in adoption gap. As a producer, why do you think, or where is the problem that we do not get to adopt everything that is available? Since you're an advisor, what's your take on this? I think that there are several factors. One of the technologies that we are using for weed control is service crops. Particularly, we cannot do service crops every year. There are times we can use service crops and other times we cannot. There's a technology that has been very helpful in our area where we had perennial tolerant weeds of broadleaf we used a very important technology. If it's not a targeted spray technique, I do not the targeted one for annual herbicide, but for perennial. And we are not using this much. I think there are herbicides that can be used for targeted that cannot be used for total. So we are losing a lot of variabilities because I think that companies find it hard to understand that there are herbicides that, due to the question of cost, that are good for targeted species and cannot be positioned for total. But those are things that help us because we do not have the weed problems we used to have 15 years ago. There is another problem that is bigger, but as producer, as we start acting, we have a limiting factor. We can work on a square meter, we can work on the plot, on the whole farm with rotation, but there are some factors that have to do with the sustainability or that is related to the landscape, biodiversities. It's not sustainable for a 100-hectare plot to have productivity over the 100 hectares. We need to diversify. We need to have perennial species, perennial grasses. So that will help us a lot. We never look up and say, Bandera is 400,000 hectares with annual crops, and the water tables are at 3 meters. So it's very difficult to be able find solutions. But if we do not understand the problem does not end up on the plot, but in the landscape, we will always be far from the sustainability we try to attain. Daniel, do you think there's less consensus on phytopathology and weed resistance? It seems to be that certain phytopathologies do not agree on the diagnosis methodology. In the case of weeds and pests, we see more consensus. I think there is an awareness of the need to have a threshold, application threshold as to when we need to apply or the level of or when we should start applying. There might be disagreements in the model use, but there's awareness of that we need to have thresholds when we should use it, the models we should use. In a previous talk, they showed, for example, a score system for application of herbicides to end-of-cycle diseases. So I think it's a question of generating the necessary research to get to those models. And for that, we need funds. And I mentioned in the case of resistance, to confirm the cases of resistance, the need of molecular sequencing. So all of that costs money. Sometimes public institutions do not have that available. So many of these confirmations cannot happen because we lack that step. But I don't think there's not much difference ahead. It's true what Beto said, that sometimes we don't see this in certain species. So I'm going to ask a question that I would ask you to answer it. you all. Do you think that through REM we have seen as researchers when we are in contact with the farmer, we were able to connect the farmer with the researcher? As Beto said, do you have the perception that you are closer to the farmer, to the plot? Yes, I think this is the case. I think there has been an approach. In fact, it depends. Pablo is very much aware of that. So he has worked in Tucumán in our institutions such as ours that is stewarded by the productive sector. We have that permanent pressure to give responses. So in our case, we need to be in close contact with the farmer. But at national level, and I highlighted this, it's merit of the REM, an organization, that articulation of the organization of farmers with the academia. I think the REM is a facilitator, definitely. I agree with Daniel. Personally, it was very helpful to interact with institutions such as REM, because the university, the academia, you see, you find yourself obliged to or forced to publish. And when you are in contact with the medium, you need to rethink how to convey the information, hard information. But in these types of context, it makes you convey the information in a more accessible manner. And I was invited by REM, so I cannot say anything negative about you. When REM is born, everything was in the air, and you could hear the comments. And the research, if there's something that is difficult, is the agricultural engineer, and then if something even more difficult is the agricultural researcher. So we are always questioned when we introduce something new. And when we question something, you have to see if this question is going to improve or it wants to merely criticize. If your question is something positive, but after that beginning, after these first 15 years that started with weeds, and it was quite a challenge for us, how are we going to handle this resistance? I think these 15 years is a reflex of all of that. Yesterday was the Agricultural Engineer Day, and the School of Engineering has 100 years, and we believe that without an engineer, there's no farming, and farming is way older. Well, we have run out of time. I would like to acknowledge the support, your support, because without you and without the researchers that are part of the REM, this wouldn't be possible, because you share your knowledge. To all the supporters and the farmers who are constantly asking questions and offering their plots, the REM team, I say this personally, but I want everyone to know there's a team here who are monsters. Tiziano, Juan, I want you to know that they work work a lot. They work in the programs. They take it personally as if it were a child. And so it's very difficult not to do well when they devote so much love and so much time. Thank you, because it's very important the way you do things. And I'm sorry for many mistakes, but this would not work if it weren't for you. So there's a lot more people to thank. Gabby, who devoted a lot of time. I started saying that REM had many of the Congress mottos. It has a lot of open source, because REM is precisely that, is the open source that you can enter and modify, that is accessible. You can modify it to make it better. It's a program. REM is a program. The companies, I'm sorry I forgot to mention the companies. Without them, it wouldn't be possible with their support. All of us are stakeholders and active participants developing the program. We try to provide support, but the REM has the open source for us all to access it and improve the program. And doing it together, that is the way to grow. So if these 15 years had something, is the vision. We invite advisors, everyone, you do REM, from Aapresid, and we try to take the mission and the values and the vision of what the REM has to do. We try to communicate that. So thank you all. We do not take much of your time, and let's go have a toast. Thank you.